And when you're looking for the patterns here, what you see is, again, first test to see, does it have to do with just adding or subtracting, multiplying or dividing numbers. So moving from 1 to 3, we add 2, 3 to 6, we add 3, 6 to 10, we add 4, then add 5. So we see the pattern is we're adding one additional number each time, so we'll add 6 to the next, giving us our next number 15 plus 6, or 21. In the next pattern, again, what we look at is we add 10, then add 11, then 12, then 13, then 14. So again, we see that the pattern is to add one more each time. So 60 plus 15 gives us our answer for the next number in the sequence, which is 75. Once, if you look and there's no pattern on what you're adding or subtracting to get to numbers, look for any observations about the way the numbers look. So here, when we're looking at this set C, we see that this decimal point moves from being after the 1 to before the 1, and it keeps moving to the left each time. So we're going to move the decimal to the left one more to get the next number, which is 0 point, and now we have 3 zeros in front of the 1, and so that gives us our solution. In problem 4, again, if we look to see, 2 plus 1 gives us 3, 3 plus 5 is 2, 5 plus 2 is 7, plus 4 plus 2. So we see that there's no specific patterns for adding numbers. So again, look to see, is there anything physically about these numbers that aren't included, or again, you might also take a look at the numbers that are not included, that are missing from the sequence. So here we're missing a 0, a 1, we're missing a 4, a 6, 8, 9, 10, a 12. So if you look, you might be able to see some common properties among those numbers. And all of these numbers here over are composite numbers. They all have factors. None of these have factors, and so what you should be able to notice is there is a classification for these. These are prime numbers. So our next number here is going to be the next number after 13, which is 17. On E, if you look here, again, the pattern doesn't exist for adding and subtracting simple numbers, but if you do notice here, you are dealing with fractions. So if we think of 1 as being 1 over 1, looking across the top, we go from 1, 2, 4, 8, 16. What we see here is we're doubling the numerator each time. So let's double 16, we get 32. And then in our denominator, what we see here is we're taking each one and we're tripling it. So this, if you look, would be 3 times 81, which is 243. And so that gives you your answer, the fraction 32 over 243. If we look at F, again, it's the same thing. All the numbers except for the first are fractions. So let's rewrite the first number as a fraction and see what that gives us. And so here we know that our numerator doesn't change. It's still going to be a 1. And let's look and see if we can find a pattern in the denominator. If we look at just the differences, 1 plus 4 is 5, 5 plus 9, 14 plus 16, 25, 36. So what you should notice here is the numbers that are being added are the next consecutive perfect square. So here, imagine this is 6 squared, so we're going to add 9 squared to the next number. We get 91 plus 49, which gives us 140. So our answer is going to be 1 over 140. Right. For problem G, here if we look from 90 to 81, we're simply reducing each of these by 9, minus 9, minus 9, minus 9 each time. So if we subtract 9 from 54, we get our answer of 45. You can also see a pattern in the digits. The tens digit decreases by 1, 9, 8, 7, 6, 5, so this will be 4. The units place, or the ones place, increases by 1, so 0, 1, 2, 3, 4, this will be 5. You can use either of those patterns. And so again, if we kind of look to see how these look to be increasing in some way, so we add 0, then 1, then 1, 2, 3. So if you look at the pattern of those numbers that are being added, we see that if we take two consecutive numbers, so 0 plus 1, it equals the next consecutive number. So 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5. So 3 plus 5 is equal to 8, so we'll add 8 to 13. 13 plus 8 gives us our next number of 21.